Not sure where that video just cut off. I've got a circle here, and in the circle I have a central angle. This angle is equal in measure to the arc that it subtends. I can also have an inscribed angle. Now notice what I'm doing here. I'm getting a little bit more tricky. Let's say I said that this here was 42 degrees. That arc. Well, that would make my blue central angle also equal to 42 degrees. My inscribed angle down here is half the measure of the arc that it subtends, which means it has to be half of 42, or 21 degrees. In this same circle, I can have two chords, like this one and this one. And I can tell you that this arc here has a measure of 75 degrees, and this arc here has a measure of 60 degrees. This is neither a central angle nor an inscribed angle. It's an angle inside the circle, or an interior one. So its measure is just 1/2 of the sum of the arcs it subtends. 60 plus 75, which means my x is going to be 1/2 of 135, which means x is going to equal, I believe, 67.5 degrees. Let me just make sure I'm doing that calculation correct. +75 plus 60 divided by 2, 67.5. Wonderful. So, those are the ones we've got so far. This setup here, where what I have is a circle, two chords. And if I called this arc A and arc B, theta is equal to 1/2 of A plus B. Keep that in your head as we take a look at the next kind of angle. What I've been given is a circle. Oops, I accidentally opened my compass a little bit, not realizing it. Now, you now know terms like secants and tangents. So if I said in circle E, secants AB and CD intersect at F, you should know what that means. A secant is a line that crosses through the circle in two spots. So let's say I have a secant here. And then I've got another secant here. And these are AB and CD. They are intersecting at point F. And I want to know what F's measure is. So, first of all, realize that this angle on the outside, as it opens up, it subtends not only this one close arc, but also this further apart one over here. Both of them are necessary in order to find that angle. I'm going to color code this a little bit. Do this part in red, and I'll do this part in green because I don't think the blue is really showing up on this camera very well, but it could just be that this camera has a weird screen. So, I've got these two arcs that are being subtended by that angle. I'm going to go ahead and I'm going to measure them. I'm going to say that this one's 80 degrees, and this one here is 45 degrees. And I want to know what the measure of my theta is. So, like I said, it's very similar to the last one. It has to involve both. I'm going to, do I want to give it to you in a general form or the specific one here? Let's talk generally for a moment. If I've got a circle, and the angle is on the outside of that circle, so exactly like what I had before, here to here, I'm going to call this further arc A, and this closer arc B. I just realized I switched up the colors. I had red as the closer one before, so let me just arc A and arc B. And here's my exterior angle theta. An exterior angle is equal to half the difference of the arcs it subtends. Difference, again, means subtraction. Do you see why I said this is so tricky, and it's very similar to the other one, where before, if I have this circle, and I had two intersecting chords, like this one and this one, here, if this is my theta, and I call this A and this B, theta was equal to 1/2 of A plus B. Very similar. How do I keep them straight? How do I recommend you do that? There's two ways. First of all, when it's an exterior angle, you have two different arcs. You always go from the furthest and subtract the smallest. Because that order matters, in other words, there's a way to tell what the order is, the further one and the closer one. The order matters, that's why you need subtraction. Whereas down here, because if I choose this angle, I could just as easily choose its vertical one, which are equal, there's no way to really know which one comes first. And there's the addition in it. Other way you could think of it, which is super lame, but this is the way I always did it. Hey, look, the intersection there sorta kinda looks like a plus, so that's the one with the plus, whereas these come down to a point, it makes them minus, which is why it's a minus. Whatever you want to do to keep them straight and to memorize them, you can do that. I'm just going to throw out there, tell you how I use it, and you can choose whichever one you'd like to use. So, I wouldn't recommend thinking of some sort of notation, though. Don't think of it as a B minus an A, the way I've written it here. I would think of it as 1/2 of the further or farther minus the closer. I always forget further and farther. One of them refers to physical distance, and another is metaphorical distance. I always get those two mixed up, but that's something I'll have to look up, because I don't like making little mistakes like that. I like knowing language, whereas here it's just 1/2 of both arcs that it subtends. So let's jump back to the actual example. Here was theta. The farther arc is 80 degrees. The closer one is 45. Go ahead and solve for theta right now. And you should have found that theta was a decimal, which is okay, because my angle, my exterior angle, is 1/2 of the difference of the arcs it subtends. You take your bigger one's always going to be further away from it, minus 45. So theta is equal to 1/2 of 35, which means theta is 17.5 degrees. Now, The reason this is the most complicated one of these angles is not just because of this little formula in here. It's because of how these problems can come up, because there's actually 3 ways you can form an exterior angle. You can do it like this, where you've got 2 secants that intersect. But I can also have a circle and have one tangent here and another tangent here. Hey, look, those tangents form an exterior angle. You can also have a combination of the two, where you say, here's my circle, tangent line, secant line, and you form an angle. Any time you have an exterior angle, you use that same rule. It's the farther arc it subtends minus the smaller. The one that's the most tricky is the secant and tangent combined, because you'll notice that that forms 3 arcs. 1, 2, and 3. You only care about the ones that are in the path of the angle. This one and that one. Let's do 2 quick examples. Oh, I almost caught this thing point down in my hand. Ooh, that would have been a fun scream I would have caught on camera. All right, circle time. And in my lovely circle, I'm going to have tangent here, and then I'm going to have a secant here. And again, these can be raised, they can be line segments, they could be lines, like this could just keep extending this way. Let's say this arc here had a measure of 80 degrees, and I'm going to be evil. Oh, I'm going to be so evil. And I'm going to say that this arc here is 140 degrees. Find me theta. Pause it, figure it out. Okay, here's why I said I was being evil. Here's my exterior angle. This angle subtends 2 arcs. This one, because my rays open up this way, but then it also subtends this one over here. I know that if I want to find theta, it's just 1/2 of the bigger arc. Oh, I don't have the bigger arc. That's why I was being evil, because I need to find it. Well, it's okay. All 3 of these arcs form a full circle. Because this is a tangent, this arc and the red one meet up at one single point there. If that were a secant, this one wouldn't be possible. But because it's a tangent, I can be evil and I can give you that. You can say this has got to be 360 minus 80 minus 140 to find that this arc is also 140 degrees. So theta is just going to equal 140 minus 80 and multiply it by 1/2. So theta is 1/2 of 60 degrees, which is 30 degrees. The fact that this unneeded arc is equal in measure to the one you did need, again, purely a coincidence of the numbers I have here. Don't think that that's a property. It's not. So, one more kind of exterior angle, which is when you've got 2 tangents. And for this one, I'm going to have a little bit of fun. Let's say it is currently early to middle July. It's not, but it kind of feels like that, the way school's been going, right? So, here is the lovely, beautiful, wonderful globe that we call the Earth. Now, as I'm sure you know, the Earth isn't always the same time of day everywhere. Some parts of the globe are bathed in sunlight, others are not. So let's say I had my globe here, and I had my sun all the way off screen over here, and the sun is basking part of the Earth in light. And I said, anything within this beam of light, there's my daytime. Whereas over here, this is where it's nighttime, sleepy, go bye-bye. If I said that the degree arc of sunlight is 178 degrees, I want to know all the way this way, all the way off camera, what's the angle of the sunlight that reaches us? Realize that all this is an exterior angle problem. You've got your circle. You've got two tangents that make an exterior. You know that's 178. This is my unknown. I can go ahead and solve for my x here and then set up that same problem. Try it out. Since these are tangents, they meet at a single point, meaning if this is 178, subtract from 360 to find that this is 182 degrees. That's 182, that's 178. My theta, which is off screen, is just 1/2 of the difference between them. 182 minus 178, which means theta is 1/2 of 4, which means theta is 2 degrees in this instance. Right? Because look how nearly parallel these look. That means the angle you have is super, super, super narrow. But because Earth is 90 some odd million miles away, that angle opens up as we get further away. As far as what this means, this 2 degree, like what does that mean? The sun looks like it's 2 degrees. If you look up into the sky and you imagine, let's say this is my observer, and you look up into, looking all the way onto his horizon line, and then you picture that dome that goes above, right? The sun is small. It only takes up about 2 degrees of an arc at the time that these measurements were taken. So, that there finishes up those theorems and definitions that I wanted you guys to know right now. There's more we are going to learn. But we need to know what a central angle is and what an inscribed angle is. You need to know the relationship between those angles and the arcs they subtend. And then you need to know the same for the more complicated angles, the ones that are formed by two chords, or the ones that are formed outside by a secant, a tangent, or a combination of the two. That's all I've got for you now. Thanks, guys. I will see you very soon.